When purchasing an electrically powered forklift truck, which battery charger is actually best for the job is often just an afterthought. This is perhaps because a certain amount of confusion surrounds the advantages and disadvantages of the various charging technologies. Take the old 50 Hz transformer technology for instance. Here, the battery is charged without considering its present state at all. The results are excessive overcharging of the battery and high energy costs. In the case of high-frequency technology, the battery is charged with the current held constant, which reduces the damaging battery warming. As a consequence, the service life compared with 50 Hz transformer technology is increased. Modern active inverter technology from Banner is a development of conventional high-frequency technology that takes the state of the battery into account during the equalization charging phase in order to keep overcharging to a minimum. All three of these battery charging technologies work on the same principle. They charge on the basis of a predefined fixed charging characteristic and almost totally ignore the state of the battery. Expressed in a physical formula, the battery has to date been charged with a defined level of current to give the charging voltage. Banner has opted for a completely new technical approach with its innovative RI charging process. For the first time, it's the voltage that is specified, not the current. The current becomes a function of the internal resistance of the battery. This internal resistance will vary depending on the age, temperature, and state of charge of the battery. Every individual charging cycle is hence unique and has its own characteristic, and this has two hugely significant advantages for the user. Firstly, maximum energy efficiency thanks to the highest overall efficiency figures between the socket and the forklift truck. Secondly, a marked extension to battery service life as a result of the insignificant levels of battery warming. When charging a traction battery, the flow of energy from the socket via the charger to the battery, and hence to the forklift truck, is represented in the form of overall efficiency. Overall efficiency is the sum of two processes. As a first step, the energy coming from the socket in the battery charger is converted from AC to DC. This electrical process determines the level of efficiency of the device. This is followed by an electrochemical process in which the battery is charged by the battery charger. This is referred to as charging efficiency. Chargers that use the old 50 Hz transformer technology have a level of device efficiency of roughly 80%. If they employ a standard charging characteristic, these chargers achieve a charging efficiency of 70%. So if we add these two processes together, we end up with an overall efficiency figure of just 56%. Conventional high-frequency technology gives a better device efficiency figure when converting into DC. The charging efficiency derived from the charging characteristic is 75%, with the overall efficiency figure compared with the 50 Hz technology thus improving to 68%. The existing active inverter technology gives a charging efficiency of 80% and increases overall efficiency to 74%. But the innovative RI charging process, with its revolutionary charging characteristic, delivers a charging efficiency of 90%, increasing the overall efficiency figure to a healthy 84%. The result is maximum efficiency from the socket to the forklift truck. The electrochemical process employed in charging a traction battery causes the battery to heat up. According to a standard issued by the German Institute of Electrical and Electronic Engineers, every additional degree of warming reduces the service life of the battery. With battery chargers using the 50 Hz transformer technology, charging losses start right from the beginning of the charging process, as the battery is unable to absorb the high levels of current. By the time the charging process is complete, the overcharging of the battery will have resulted in excessive battery heating, which greatly reduces the service life of the battery. Using high-frequency technology reduces the high losses at the start of the process. However, there is still significant overcharging of the battery during the recharging phase. With active inverter technology, losses were also apparent at the start of the charging process, although overcharging was reduced in the recharging phase. The new RI charging process shows the lowest losses at the start of charging, as the current input of the battery is now optimized. The battery only receives the current that it actually needs. This principle also results in very low levels of overcharging in the recharging phase, while the new charging process guarantees the coolest and gentlest charge, extending the battery service life to its maximum.